Very good evening to all. Today's speaker, respected Mr. K.Vimal Kumar, currently is working as Operation Director, Analytical Instrumentation and Maintenance System, Kuwait, and coordinator of this webinar, Ms. Shiba Vinodani Priyadarshini, my dear colleagues and my dear participants from various locations. It gives me a great pleasure to welcome on my own behalf and on our institution behalf today's speaker, Mr. K. Vimal Kumar sir, to deliver a webinar on scope and opportunities of chemical engineering, organized by the Department of Chemical Engineering, St. Peter's College of Engineering Technology, and our college is affiliated to an university. And we are organizing this webinar in association with Indian Institute of Chemical Engineers Student Chapter. My hearty welcome to all the participants. I hope this webinar will be more interesting and more informative to all the participants. Scope and opportunities of chemical engineering as far as concerned, uh, chemical engineers are getting a very good job because within Tamil Nadu, only limited engineering colleges offering the special chemical engineering program. So every year, only limited chemical engineers are graduating, and then they are getting job without any difficulties because chemical engineers can work in petroleum industry, petrochemical industry, polymer industry, and food industry, leather industry, fertilizer industry, and even they can also join as a scientist in various research institution like Bob Atomic Research Institution, ISRO, CSIR, like that. So chemical engineers have very good scope, and our institution as far as concerned, St. Peter's College of Engineering Technology is located in Chennai, nearby our railway station, and our chemical engineering departments have very good infrastructure as well as lab facilities, and we have highly qualified professors also. So I invite all the participants, if possible, come and visit our institution once, and I wish you all the very best. With this, I hand over my session to our today's speaker, respected K.Vimal Kumar sir.
Thank you very much. Respected organizers of St. Peter's College of Engineering Technology and my dear students, it's my pleasure to join you for a small lecture on scope and opportunities of chemical engineering. I will start from the basics. Yeah, chemical engineering is basically a study of physics, chemistry, biology, and maths. So when I join an engineering college, what are all the core subjects I will be studying means following are the core subjects in chemical engineering. I'll be studying about fluid mechanics, thermodynamics, heat and mass transfer, process engineering, process controls, process automation, chemical technology, and plant design. These are all the core subjects. Probably, if you are a fresh person, fresher, maybe you will feel all these subjects as a jargon for you. But I will not get into that in detail. But whereas I will be trying to help you to identify which are all the areas where you will be specializing when you complete all these core subjects. So I will be today talking about 5 major areas where you will be specializing when you study all these subjects. The first one is the machinery and equipment. See, as you are all chemical engineers, so you will be basically taught about machinery and equipment in your curriculum. So what is machinery and equipment? When you really want to understand something more about machinery and equipment, machinery is something that rotates. Equipment is something that is stationary. So in all process plants, irrespective of the type of chemicals it is handling, all process plants will be having basically machinery and equipments. So I will be giving you a brief of what is the machinery I mean. So if you look at the machinery, see, there are basically you will be learning about pumps in chemical engineering. So when you talk about pumps, there are two major classification of pumps. So one is centrifugal pumps, the other one is reciprocating pumps. So everyone has a different application. For example, if you take up centrifugal pumps, it is used for large volume and medium pressure. The one which you are seeing on your left is the centrifugal pumps. They call it as multi-stage centrifugal pumps, between bearings pumps. So if you go into the details and the classification of these centrifugal pumps, there will be n number of models. There will be cantilever pumps, there will be simply supported pumps, there will be single stage pumps, there will be multi-stage pumps, there will be pumps with gland packings, there will be pumps with mechanical seats. So it goes into large number of classification. So today what you will understand is there are two major classifications of pumps. One is centrifugal pumps, another is reciprocating pumps. Centrifugal pumps is used for handling a large volume and medium pressure. And reciprocating pumps are used for high pressure, medium volume. But in both the cases, if you notice, these pumps are basically used to transport process fluid from one place to other. This is what is a centrifugal, this is what is the purpose of a pump. So if you go into the detail, there may be a lot of categories like centrifugal pumps, screw pumps, diaphragm pumps, piston pumps, gear pumps, vane pumps, and so on. So this is only to give you an idea. There are pumps used in a chemical industry, and these pumps are basically required to transport liquid from one place to other. The second major classification under the equipments is compressors. So this is what is compressor. The compressors also serve the same purpose. It is also used to transfer the gas, whereas in the pumps you are using process fluid. In compressors you will be using process gas to increase the pressure or transfer the process gas from one place to other. But again, in compressors you have a lot of classifications like centrifugal compressors, integrally geared centrifugal compressors, reciprocating compressors, V-line compressors, diaphragm compressors, screw compressors. Here the same principle applies, but the only thing is here in compressors, if you see, the centrifugal compressors run at a very high speed. It will run at it will go even up to 15,000 and 20,000 RPM. RPM is revolution per minute. Every minute these compressors will rotate more than 10,000 or 15,000 or up to 20,000 RPM. So this is the purpose of a compressor in a chemical industry. So we have noticed two types of things. One is pumps used to transfer the process fluid. Second is compressors used to transfer the process gas from one place to other, or it is used to boost up the pressure of the process gas. The next one is the steam turbine. See, all along you have seen only the driven equipment. In the sense, they are all driven by something. In refineries, oil and gas industries, most of these equipments are not driven by motors. They are not driven by electrical motors. Instead, they are basically driven by steam turbine. The one which you are seeing is a steam turbine, which is the driver equipment, which drives a pump, which drives a compressor. So these type of steam turbines are highly critical machineries. Even if you do a small mistake, this will land up in a huge crisis for a chemical plant. So these are given the lot and most importance for running a chemical industry. So this is very critical. Also, these type of steam turbines are also coupled with a power generator for generating electricity. For example, in a thermal power plant, these type of steam turbines are normally coupled with a power generator to generate electricity. So then, not limited to these steam turbines, there are also gas turbines used to drive the equipments. When you see the gas turbine here, there is a difference between the steam turbines you saw there and the gas turbines which you are seeing here. Those turbines are called, those blades are called impulse blades. Impulse blades, whereas these blades are called reaction blades, which you will be understanding more in detail in the course of your chemical engineering. But these type of gas turbines are used in a huge way in Middle East countries because gas is available in plenty in the Middle East countries. So gas turbines are used as a driver equipment for driving the compressor and pumps. So apart from this, so whatever I referred earlier are used in a major way in refineries, oil and gas. Coming to a little low-end plants, like ordinary chemical plants, petrochemical plants, fertilizers, all these plants use some more additional rotating equipments called centrifugal fans. These centrifugal fans, they do not create a high pressure. They will be creating pressure just above the atmospheric pressure, but they handle a large volume of air. The similar way, centrifugal blowers also develop a pressure just above the atmospheric pressure, but they handle air to a limited volume. So they are called centrifugal blowers. The next one you see is the screw conveyor. These screw conveyors are used to convey the material from one place to other place. The same way, the one which you see on the left corner is the belt filters. The belt filters are used to filter the slurry and separate the solid product from the liquid product. So these are used in phosphoric acid plants. The next one, what you see is the rotary drums. These are used in cement industries and they are also used in diammonium phosphate plants. These are mainly used for granulation purpose, for homogenization purpose. So the next one, what you see is the rotary valve, wherein you have to maintain vacuum in the system. So that means these valves are used for the purpose of maintaining a vacuum in the system, as well as they also handle the on and off service for regulating the flow inside the vessel. So whatever you have seen now all pertains to rotating machinery. Any plant, they cannot operate without these rotary equipments. And the initial what you see was the high-speed centrifugal pumps, centrifugal compressors, reciprocating compressors, steam turbine, and gas turbines are high-end rotary machinery which are used in refineries, oil and gas. So we will now look at some of the stationary equipments. These are stationary equipments in any chemical industry. These equipments are available in hundreds. So for example, in a refinery, if you take these exchanges, will be minimum, there will be 1,000 exchanges. So 1,000 numbers. So, but these exchanges are basically they are called as heat exchangers. The heat exchangers are used to exchange the heat from one medium to the other medium, from liquid to liquid or gas to liquid or liquid to gas, without a physical contact. Without a physical contact, they exchange the heat. The one which you see on the left top is a heat exchanger. They call it as a U-tube heat exchanger. Then the next one is the stacked heat exchanger, where the volume, you will have to manage a large volume of fluid. The next one, what you see, is called the breech lock exchangers. These breech lock exchangers are used for handling process liquid or gas which is at a very high pressure, So you need to have a proper sealing arrangement which is achieved through breech lock heat exchangers. The next one, what you see, is called fin fan coolers. These fin fan coolers, what you see, there will be finned tubes to exchange the heat, but there will be fans. There will be fans mounted either on the top of these exchangers or at the bottom of the exchangers to exchange the heat. But those fans will use the atmospheric air to exchange the heat. The next one, what you see, is called the plate type heat exchanger, which is used for more corrosive nature of the fluid. And when for example, these are used in sulfuric acid plants. And the next one, the final one, what you call, is a serpentine cooler, where the volume of liquid is very less, but you need to have lot many flows to exchange the heat. These are again used in sulfuric acid plants, phosphoric acid plant, where you have a small heat difference, where you have a small requirement of heat to be exchanged between two media. So trying to consolidate on the heat exchangers, you can see four major type of heat exchangers used in the chemical industries. One is fixed shell and tube heat exchangers. The second one is the U-tube heat exchangers. The third one is the floating head heat exchanger. The fourth one is the kettle reboiler. Every heat exchangers have a different purpose, and every heat exchangers, we have a different type of operation methodologies. We have a different type of maintenance methodologies. Now, we are now going to see how really you will have a feel of what is a heat exchanger. How will you take out a heat exchanger for maintenance? So now what you have seen is a hydraulic method of pulling out a tube bundle from a heat exchanger and then putting back the same tube bundle after cleaning the tubes inside and outside. These are called bundle pullers. They are now used in a big way in all the refineries because of the weight handled, plus from the safety point of view, now all the chemical industries recommend to use a hydraulic method of pulling out these tube bundles. Now, in my period where I was a maintenance engineer 30 years back, so we were not having this technology in hand. We were all manually pulling out using chain blocks and other mechanical tools. But now these are no more allowed in refineries. Whatever you are seeing is the recommended method to be adopted while pulling out the tube bundle. But you will also notice how you will clean the tubes. How you will clean the tubes.
We believe we're on the eve of a revolution in industrial cleaning. A world in which robots collaborate with humans to do professional jobs, safely, in control, and of immaculate quality. This world is no longer science fiction. Today, Maurik takes the next step into the future, Hydra. The new Hydra 5 enables Maurik to be the first to remove automatic internal tube bundle cleaning from a lab environment into real practice. Hydra reads its environment and ensures unrivaled cleaning without human intervention. 5 rotating lances autonomously clean the tube bundle with a powerful high-pressure jet. All of this occurs at maximum speed and pinpoint precision. Hydra constantly monitors all parameters and adjusts its method so as to avoid damage. The increased speed and efficiency result in a substantially lower consumption of water and fuel. As such, it mitigates the environmental impact of our...
If you see here, in those days, manually, this cleaning was happening manually. But this cleaning is no more into the practice now. Now things have improved a lot, wherein if you see complete robotics in the cleaning of heat exchanger tubes. Now this has grabbed the whole market because of the speed and precision and safety. So, yeah, please.
Sir, screen கொஞ்சம் ஹேங் ஆயிருக்கு. திருப்பி நியூ ஸ்கிரீன் கொடுத்துறீங்களா? இந்த வீடியோட அப்படியே ஸ்டாப் ஆயிருக்கு. ஓகே.
So this is what we have seen, and these exchanges are nowadays cleaned with high precision robotic machines. No more manual cleaning is involved. But if you see from a chemical engineer point of view, all these operations come under your control. You are the person who is going to operate the plant. You are in charge of a plant. Every single activity in a process plant will happen only with your knowledge and clearance. So now, in the stationary equipments, next to stationary equipment, heat exchangers, what you are seeing now is a fired heater or a furnace, wherein heat is again exchanged. But here what happens is, you will be firing with a fuel oil or a gasoline inside a closed vessel or a closed furnace, which will help to crack the heavy hydrocarbon chain, which will help you to break the or vaporize the heavy hydrocarbon chain. This is the purpose of a fired heater. Once the chain is broken, once the hydrocarbon chain is broken, then the gas gets passed to a catalytic reactor. These are all the equipments highly critical for an operation engineer from the operating point of view, because these catalytic reactors are filled with catalyst to aid the reaction, to help the reaction, to aggravate the conversion. So these reactors, again, they fall into many categories. There are fixed bed reactors, there are catalytic tube reactors. Like that, there are so many technologies in this catalyst. Then again, there are so many technologies in the construction point of view. So in general, your engineering will teach you all these basics of what is a fired heater, what is a catalytic reactor, what is a fixed bed reactor. All these things, if you know, then it will be easy for you to go and take over or work in a process plant. So the next one will be the fractionator, absorber, regenerator. See, actually in a refinery, the heart of a refinery is the fractionator. What is actually happening in a fractionator is, in a fractionator, all different types of product or end product is taken out based on the boiling point. For example, kerosene, petrol, methanol, ethanol, coke, hydrogen. So in all this fractionator column, in every stage, based on the boiling points, the product is taken out. For example, ATK, aviation turbine kerosene, the kerosene which is used in the aircraft is taken at a different stage. The kerosene which is used for domestic purpose, it is taken at a different point. The petrol, it is taken at a different point. Then you have coke, the residue that is collected at a different point. Then methanol, then hydrogen, something like that. Fractionator is the heart of a plant. So you will learn a lot in your chemical engineering about this fractionator. The same concept applies for the absorber. What is really happening in absorber is, when you collect the gas, the gas will have lot of unwanted gas in that. For example, the acidic gas will be present in the end product. So we want to remove that unwanted end product. How to remove that? That is called amine regeneration, amine absorption. For example, you will charge lean amine solution to go and scrub the acidic gas, which is called absorber. So that gas, when it comes out, it will be completely absorbed by the acidic gas. So if you want, if you take out the fuel gas, it will be acidic gas free. So all these basics of fractionation, basics of distillation, basics of absorber, regenerator, all these things you will learn in a chemical engineering. Now, when you really understand all the basics and the fundamentals of all the machinery plus equipments. So all along you have seen rotary equipments, wherein you saw pumps, then compressors, then turbines, then lot of low-end rotating equipments. Then you saw some heat exchangers, then fired heaters, then absorber, regenerator, fractionator, distillation column. Then you saw catalytic reactors. All these things, irrespective of wherever you are going to work, all these things will be present. So once you understand the basics of operation of these equipments and machinery, then that means you are fit to understand the process flow. What is process flow? So in a industry, in a chemical industry, you need a combination of rotary and stationary equipments to convert the raw material to your end product. This is called a process flow. So for example, what you see here is a combination of crude exploration unit and a refinery. See, for example, you are taking out the crude from here. You are taking out the crude from here. Then it is transported through a pipeline. Then it is stored in tanks. Then it comes out here. Blending takes place. Then you use a desalter to remove all the unwanted salts present in the crude. Then again gradually it passes through a heater, then crude, and then you get into the refinery processing and then get into the end product. This is what is called process flow. You take it as a crude and you send it as a finished product in the form of petrol, kerosene, or whatever it is. So this is called a process flow. So gradually you start understanding what equipments are used, what rotary machines are used, what stationary equipments are used, how actually the process flow happens, how the raw material gets converted into a end product. So these are all things you will learn in chemical engineering. So this is as I told you, this is the heart of a refinery. The heart of a refinery, the crude is being heated up, then it enters into a distillation column. Based on the boiling point, on different stages, the end product is taken out, right from gas, naphtha, gasoline, kerosene, then gas oil, lubricating oil, heavy gas oil, and residue. So this is the heart of the plant, wherein you will become a master to know the in and out of a distillation column, wherein you will understand all the basics of this operation and the process flow. How does this process really happen? This process will be clearly understood by you in a process flow study. So, for example, I feel you should really see this video clipping, because you will clearly understand what is really happening in a refinery.
From the outside, an oil refinery looks like a small city. A city composed of pipes, tanks, and towers. But if you went inside, you might be surprised to find one of the most technologically advanced industries in the United States. Here, engineers and scientists have figured out how to turn raw crude oil into the valuable fuels, lubricants, and components we need to make millions of products. Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to
I think now you should really feel proud of operating such a big refinery. Chemical engineers are the people who operate this complete refinery. So you should feel really proud to control the whole refinery. For example, in India, there are so many refineries, but they are basically governed and operated by chemical engineers. Only then the downline engineers come. For example, mechanical engineers, electrical engineers, instrumentation engineers, civil engineers, all these people are there to serve the chemical engineers. So chemical engineers should be very proud to operate a refinery in India, because you are the people. You are the people who feed variety of products to the country. So because I'm running short of time, probably I will skip. I will not be able to display the complete video. Now, the moment you understand the complete process, you are fit enough. You are fit enough to develop a process flow diagram, PFD. This is what really matters. So, this process flow diagram, you become very conversant to read this process flow diagram. This is what will be available in the refinery or anywhere in these are all the documents available for you. So if you really become conversant to read a process flow diagram, so you will very easily understand when you get into any refinery, you will understand what is really happening, what is the raw material, what is the end product, what are the type of equipments used, what are the rotary machinery used. If you see this process flow diagram, you must be able to understand there is a distillation tower, there are pumps, there are heat exchangers, there are various filtration unit, there is a desalter, all these things you will be able to understand. So now, that means you have now become an expert, or you have specialized on equipments and machineries, then you have specialized on process flow. So now you get into the third stage of your engineering curriculum. You get into the third stage of engineering curriculum, which really makes you to specialize in process controls. What is really process controls? So this is process control. The earlier diagram you saw was a process flow diagram, which was not having any control circuit. But if you see this circuit is having lot of controls. So, for example, those diagrams are called as PFD, process flow diagram. This is called as P and ID, piping and instrumentation diagram, P and ID. So if you see in this image, you can see there are a lot of controls. For example, you need a controller to control the flow. You need a controller to control the temperature. You need a controller to control the level. You need a controller to control the flow. So all these things, you will be controlling these parameters by sitting in a central control room, which is operated by DCS, distributed control system. But also you should understand myself. I am a 30 years experienced in refinery. I belong to this category. The reason is I belong to a third generation category, whereas it is not the case for you. You are a fourth generation category. So what is the difference between third generation and fourth generation? This is the difference. The first generation was a mechanical control. The second generation was a electrical controls. The third generation where I used to work is a electronics control. But today, the whole world, the scenario of the world has changed, and even the refinery has adopted to the change where you are the fourth generation people to operate a chemical plant which are presently operated or getting converted into a IoT control, Internet of Things. So most of the controls in the refinery are getting converted into Internet of Things, IoT control. This is what you are seeing now. Now, this Internet of Things have gained momentum. So your life is getting more and more easy. You don't need to go around the plant to look for abnormalities, to look for any issues, any problems. You can sit anywhere to control the process parameters. This is what has really made a big impact on the present fourth generation engineering. So all these things, for example, the crude oil unit will be located elsewhere. The tank farm will be located elsewhere. Your refinery will be located elsewhere. But still, you can sit in New York and control this. So that is what the Internet of Things is giving you an access to control your plant from anywhere. And also from the safety point of view, it helps you a lot. It helps you a lot to identify the issues. It helps you to identify the gas leaks. It helps you to identify any unwanted entry into the plant facilities. I want you to see a small clipping on this. Are you able to see this? See, for example, if there is a person without a permit is entering into your facility, you get a notification in your mobile. Just imagine. For example, if you are going to operate a valve in a plant, when you are operating and if there is a gas leak, that gas leak is shown in your watch, in your smartwatch. You are getting an indication in your smartwatch saying that there is a leak. There is a gas leak there. So the complete technology has changed. So you get an advanced method of controlling the plant and machinery in a process plant. This is what I want you to register in your mind. So the next one, for example, when we were talking about the process control, one important change that has happened today is the Internet of Things. The same way, the second one, what has impacted the chemical industry is the drones. The drones are no more a fun game now. The drones are very seriously employed in chemical industries. What for? They are very much useful in identifying the gas leaks, air pollution. Then they are used for inspection of pipelines. So in a very, very big way, the drones are capturing the chemical engineering market. They are capturing the industrial market. So it is very, very useful nowadays.
Hello, I'm Ron, co-founder and CEO of Aerobotics. Aerobotics is about to revolutionize the drone industry. In the next couple of minutes, we'll show you how. This is a large mining facility. The possibilities for drones to create real value in a facility like this are endless. Let's see a couple of examples. Routine inspections with drones not only significantly saves resources, but also prevents endangerment of employees performing them. Drones are also uniquely qualified to measure stockpiles like these. This has tremendous value in calculating inventory and preventing waste.
So are you able to understand? See, these type of drones are too much useful today for making a quick survey, quick inspection. Human intervention is not required. Then from the safety point of view, it is much, much helpful for our regular day-to-day activities in a chemical industry. So we saw two things. One is Internet of Things has captured the industrial market. The second one is the drones, which the third generation engineers are not at all used, whereas you will be exposed to such type of advanced technology. So you can feel proud to be the chemical engineering, to be a chemical engineer. So the next one, what is really happening in the chemical engineering field is, in a chemical industry, is augmented reality. Augmented reality, mixed reality, artificial intelligence, then machine learning, then chatbots. So all these things are gradually and impacting the market in a big way. They are much, much helpful in a chemical industry. If you see, your boss will be sitting in New York, you will be sitting in Chennai, you will be controlling the refinery, but you will invite your boss in New York to go for a walk around with him if augmented reality and virtual reality is mixed up. So today that's really happening. For example, today engineers, chemical engineers are involved in designing a plant. You can see it in the picture. Plus, these tools are now taken inside the plant to detect any abnormalities, any gas leaks, any inspection activities. So you should be really happy and proud to know that chemical engineers are the engineers who really convert this world into a fourth generation market. You will be really incorporating the technology of IoT, the technology of drones, the technology of augmented reality, virtual reality, mixed reality, then artificial intelligence. Artificial intelligence have really impacted like anything. It really helps you. Machine learning, for example, you have a problem in a compressor. It will advise you. The machine learning will guide you. Last year, there was a problem like this. So you do the same operation. It will guide you. It will help you. So those type of real technology has impacted the process industries.
At Linden, we are on the lookout for innovations that can help our customers in new and often unexpected ways. Imagine if you could walk around and train in facilities long before they were physically built. Linden is currently working on virtual reality training that can revolutionize how we educate and train operators.
these digital twin environments, we can ensure that your people know how to navigate the space, understand where the right components are located.
So now this is no more a fun game. So this has become a reality in our lives. So this has become a reality in a chemical engineering life. It has become a reality in a process industry. So in future, you will enjoy to work in a chemical industry. Being a chemical engineer, you will be the authority. You will be the authority to operate a plant. Whereas all other categories of engineer will fall under your category. So you must be proud to operate a chemical plant. So we saw three things. One is the equipment and machinery. The second one, we saw the process flow. The third one is the process control. So once when you are thorough on these things, now you become a full-fledged chemical engineer to operate a plant. What is really operate a plant? Yeah, we are now going to operate a chemical plant. So what is operation? When you operate a plant with the most efficiently, this is what is very important. See, you have a raw material, you have to achieve the end product. So how well you operate, how efficiently you operate, which helps you to achieve the end result in an economical way. That is only very important. For example, what you are seeing is a pump performance curve. So you know the pump you operate, and you know what is the pressure, what is the temperature, what is the speed, what is the volume it has to be operated to give you the best efficiency. For example, if you go through these curves, you can very easily understand which is the BEP, best efficiency point. So you will become an expert in operating a pump in the best efficiency point. So all these things you will get to understand when you get inside a process industry. The same is applicable for a compressor. Compressor, when you talk of a compressor, you will know what is polytropic efficiency. The efficiency of a compressor is measured in terms of polytropic efficiency because these compressors, you can vary the speed. As I told you before, these are operated by steam turbines. Steam turbines are governed by speed control mechanism, which will help you to control the speed, which will help you to vary the speed. So these type of polytropic efficiency curves will help you to guide which is the safe operating point and the best efficiency point for operating a compressor. The similar concept is applicable for steam turbines also. So you will learn a lot about what is isentropic efficiency from steam tables in your curriculum of chemical engineering. So you will very thoroughly learn about these three things in your curriculum of chemical engineering. So having learned to operate a plant, operate a chemical plant, process plant, it doesn't stop you there. It doesn't stop you there. You have to operate the plant in a very, very safe manner. That is what is called hazard analysis, hazard operability analysis. So whenever you operate a plant, equipment by equipment, machinery by machinery, you will identify the risk, you will assess the risk, you will communicate the risk, you will mitigate the risk. These will be the more and more you get into the refinery and you become more specialized in operation, at one point of time, you will become a hazard expert, hazard operation expert. So you should really understand this.
Hey guys, welcome back. Today's topic, heads up.
Hazard means hazard and operability study. It is a method to systematically identify hazards and come up with safeguards and recommendations to prevent these from happening. In fact, the hazard is not prescribed in the standards. The standards only demand you to do a process hazard analysis. What method you choose is up to you. Nevertheless, the hazard is the standard method to use in process industry. A hazard is not done by one person alone. There has to be a whole team of experts working together and discussing every aspect in detail. The members of the team can change.
Can you see here? Can you see here? The chairman of HAZOP team is going to be a chemical engineer. The process engineer is again a chemical engineer. The operations engineer is again a chemical engineer. The safety engineer is again a operation engineer. All these things originate from chemical engineering. That is what you should understand. You should be very proud to be a chemical engineer. So when you are doing a HAZOP analysis in a chemical plant, the most of the contribution comes from your side. So having known these 4 parameters, one is you got specialized in the operation of equipment and machinery. Then you went in for process flow. Then you went in for process controls. Then you learned how to operate a plant operation. Now you are going to conclude the 5th one. The 5th one is the process simulation. So that means you have become a thorough expert on operating a plant. The next stage, or a dream of a chemical engineer, is the process simulation. That means I want to do some changes, or I want to troubleshoot, or I want to modify, or I want to do some reliability improvement, or I want to design a new thing for my plant. So this simulation is going to help you in a very big way. Today, St. Peter's College of Engineering and Technology encourages and teaches you on process simulation, because the software itself costs you much. But one thing you should understand, once when you gain all those 4 specialization, you will enjoy working in a process simulation. That means you are imagining something and you will be giving all the inputs to that simulation software to get it done and achieve the result. This is what is process simulation. That means you will be involved in the research and development. You will be involved in design, planning, process optimization. So many interesting things will happen. This is what is the process simulation software. I believe this is very much available at St. Peter's College of Engineering and Technology, and they will give you a beautiful training on this, because this is the ultimate objective of a chemical engineer. This is the ultimatum, I would say, because the whole plant will depend on you for any abnormalities, any design changes, any improvements. All these things, they will depend on you. Today, there are wonderful softwares to help you, guide you to do this simulation. There are so many simulation packages. This is again another simulation package. And this is again another simulation. There are so many packages like ANSYS, AspenTech, Unisim, so many in the market. But learning this simulation during the curriculum is something unimaginable. It was something unimaginable during our days. But today it has become a reality. They teach you all those things.
With the V88 version of Aspen Plus and Aspen HYSYS, users can now specify known heat exchanger geometries to create rigorous heat exchanger models from within the process flow sheet. Users capture considerable savings on energy, capital expenditures, and operating expenses from high-fidelity process simulations developed using rigorous heat exchanger models. In addition to being able to size heat exchangers, users can now easily specify existing heat exchanger geometries and convert simple heat exchanger models to rigorous models without leaving the simulator. The new home ribbon guides users progressively through the design workflow. Follow the ribbon to enter inputs.
Are you able to understand? See, today softwares, high technology softwares are available which facilitates you to design a heat exchanger. You know, I told you earlier, heat exchangers are available in 1,000 numbers in a refinery. If you are an expert to design an exchanger, just imagine your position in a refinery. When you are a fresh engineering college graduate, going with all this knowledge stuffed in your brain, you have a great recognition in the market. Nobody can beat you. So that is where you should really go into the right curriculum. Your learning in the curriculum is very, very important. So same way, for example, see, this is a simple cyclone simulation. The simulation of a cyclone separator, how the materials are getting separated, how the heavy particles are getting settled on the down, and what is the micron size. So you give the input, you know the output, so the simulator will design the cyclone separator for you. So the technology has advanced so much, it gives you a lot of learning and expertise. Today it is not available with older generation people. You are a new generation people. You are filled with knowledge. So now we have completed all these things, and having completed all these things, I would say these are your dream jobs. You have a lot of openings in refinery, oil and gas, petrochemicals, fertilizers, under three major categories. One is you are required as an operation engineer. You find a large opening in construction management. Then you are also required as a design engineers. But I would say today's market is looking for young and energetic chemical engineers who are having the knowledge of all the 5 things we learned today. If you really, whenever you are meeting a client or you are presenting yourself for an interview, if you say that you are a master, you are a specialist on all those 5 things, people will really take you like anything. So when you go down here, these are all the various clienteles. All these, see, today you have in Chennai itself CPCL refinery, BPCL, HPCL, IOCL, SPIC, SR, Reliance, all these things are refineries. You have a huge opening if you specialize on those things. But not only limited to India, you have huge openings in MENA, Middle East and Africa. You have KNPC, Equate, KIPC, Saudi Aramco, Gasco, JPIC, Takrib, lot of things. But I should openly admit, and I should also feel proud to present you that I have almost worked in all these places in my 32 years of experience. Because my specialization is in refinery, oil and gas. I have worked throughout the Middle East, throughout India. So I would wish you all the best to do a career, to choose a career in chemical engineering, which is very, very prospective. And I think you have chosen the right college. St. Peter's College of Engineering will impart knowledge for you on all the subjects, whatever we discussed today in your curriculum, that will help you to take you into heights in your career. My best wishes for all those who organized this small lecture, plus the students, whoever watched this presentation, and you are free to approach me for any clarifications. You can write to me or you can reach me in my mobile number. Thank you very much. Thank you, Dr. Danish Kumar, sir.
Thank you very much, sir.
Thank you, sir. It gives me an immense pleasure in proposing this vote of thanks. I take this opportunity to thank Mr. Vimal Kumar for his motivational and inspirational speech on chemical engineering, and accepting an invitation for guiding students and giving knowledge about what is the scope of chemical engineering and what they needed in chemical engineering, what they actually detailed study in chemical engineering, and their opportunities and their recent trends happening in the chemical industries. Thank you, sir. I would like to thank our HOD, Dr. S. Dinesh Kumar, for organizing this webinar. I would like to thank all the participants from various schools and colleges. Hope this webinar will be useful for choosing their career. I would like to thank all my colleagues who have been support in organizing this webinar. I would like to thank all who have been present here. The feedback forms will be sent to your mail tomorrow, and after filling up your feedback forms, you will be getting your certificates. And I would like to request all your school students to stay back, and the engineering students can leave the sessions. Thank you, everyone.
Dinesh sir, you can speak now, sir.
Oh, but I cannot see my video, right?
Sorry?
Yes, or not?
Vimal sir is went over.
Okay. Remaining or what do you call it? All of the testimony, right?
Sorry, sir, we cannot able to hear properly.
Can you able to hear my voice?
Yeah, right now, okay.
So now all are testimonies, right?
No, your voice is very low.
Hello, is it audible?
Yeah, right now, okay.
எல்லாருமே +2 ஸ்டூடெண்ட்ஸ். Okay, fine. My dear students, நீங்கள்லாம் வந்து பார்த்தீங்கன்னா நிறைய இன்ஸ்டிடியூஷன்ஸ்லாம் வந்து பார்த்தீங்கன்னா நம்ம ஸ்டேட்டில் இருக்குது. எஸ்பெஷலி நம்ம கெமிக்கல் இன்ஜினியரிங் வந்து பார்த்தீங்கன்னா சென்ட் பீட்டர்ஸ்னால் கெமிக்கல் இன்ஜினியரிங் வந்து ரொம்ப ஸ்பெசிஃபிக்காக சொல்லுவாங்க. ஓகே, இந்த ஆடியோ நீங்கள் பார்க்கும்போது என்னென்னா, சார் விமல்குமார் சார் அவருக்கு டைரக்டராக இருக்காங்க. ப்ளஸ் வந்து அவருக்கு 33 years ஆஃப் எக்ஸ்பீரியன்ஸ் வந்து பார்த்தீங்கன்னா ரிகார்டரிஸ். இவங்களோட ப்ரெசன்டேஷனை பார்க்கும்போதே தெரியும் எந்த அளவுக்கு வந்து பார்த்தீங்கன்னா கெமிக்கல் இன்ஜினியரிங் வந்து.
Sir, actually your voice is not so audible.
Yeah. What happened? Before that was audible, right?
Yeah, yeah. மைக் கொஞ்சம் பக்கத்துலயே இருந்தா பெட்டரா இருக்கும் நினைக்கிறேன்.
Now what about?
Okay, now okay.
கேக்குதா?
Yeah, கேக்குது சார்.
டியர் ஸ்டூடெண்ட்ஸ், கெமிக்கல் இன்ஜினியரிங்கோட இம்பார்ட்டன்ஸை வந்து பார்த்தீங்கன்னா நம்ம விமல்குமார் சார் ரொம்ப அழகாக வந்து எக்ஸ்பிளைன் பண்ணியிருந்தாங்க. ஸ்டூடெண்ட்ஸுக்கெல்லாம் வந்து பார்த்தீங்கன்னா என்ன படிக்கிறது, நெக்ஸ்ட் வந்து பார்த்தீங்கன்னா இன்ஜினியரிங் படிக்கலாமா வேண்டாமா, நிறைய பேருக்கு என்ன சொல்லுவாங்கன்னா இன்ஜினியரிங் படித்தா வந்து ஸ்கோப் இல்லைன்ற மாதிரி சொல்லியிருப்பாங்க. பட் இட்ஸ் நாட் ட்ரூ ஒன். ஏன்னா நிறைய பேருக்கு வந்து பார்த்தீங்கன்னா எப்படி இன்ஜினியரிங் எந்த கோர்ஸ், என்ன ஸ்பெசிஃபிக் கோர்ஸ் படிக்கிறது, என்ன மாதிரியான ஜாப் போகிறதுன்றது வந்து பார்த்தீங்கன்னா ஐடியா இல்லாததுனால தான் அந்த மாதிரி இருக்குது. இப்போ ஒரு சாரோட ப்ரெசன்டேஷன்லேருந்து நம்ம பார்க்கும்போது பார்த்தீங்கன்னா ஹையஸ்ட் சேலரி வாங்கக்கூடிய இன்ஜினியர்ஸ் யாருன்னு பார்த்தீங்கன்னா கெமிக்கல் இன்ஜினியர்ஸ் தான். அவங்க கீழே தான் வந்து பார்த்தீங்கன்னா மித்த இன்ஜினியர்ஸ்லாம் வருவாங்க. அண்ட் ப்ளஸ் நம்ம கெமிக்கல் இன்ஜினியரிங் இல்லாத இடமே கிடையாது. ஃபார் எக்ஸாம்பிள் நம்ம தலையில் போடுற டைலேருந்து காலில் போடுற செருப்பு வரையும் பார்த்தீங்கன்னா எல்லாமே கெமிக்கல் ப்ராசஸ் தான். ஆஸ் அ கெமிக்கல் இன்ஜினியர் வி ஷுட் நோ, நமக்கு வந்து தெரியணும் எந்த அளவுக்கு கெமிக்கல்ஸை நம்ம வந்து யூஸ் பண்ணால் சேஃப், எந்த அளவுக்கு வந்து பார்த்தீங்கன்னா நம்ம இந்த கெமிக்கல்ஸை நம்ம யூஸ் பண்ணணும், மீறி போனால் என்ன மாதிரி எஃபெக்ட்ஸ்லாம் இருக்குன்றதுலாம் வந்து கெமிக்கல் இன்ஜினியர் தான் டிசைட் பண்ணணும். ஸோ ஸ்கோப் படின்னு பார்த்தீங்கன்னா உங்களுக்கு வந்து பார்த்தீங்கன்னா நிறைய வந்து ஸ்கோப் இருக்குது. சார் பேசுறது ஒன்லி ரிஃபைனரி, இந்த ரிஃபைனரிக்கே இவ்வளோ பேசியிருக்காங்க. இதை தாண்டி பாலிமர் இண்டஸ்ட்ரி, ஃபார்மசூட்டிக்கல் இண்டஸ்ட்ரி அண்ட் பல்ப் அண்ட் பேப்பர் இண்டஸ்ட்ரி, அதுக்கப்புறம் ஈவன் கவர்மெண்ட்லாம் நீங்கள் போனீங்க அப்படின்னா பொல்யூஷன் கண்ட்ரோல் போர்ட் கெமிக்கல் இன்ஜினியர்ஸ் தான் எடுக்கிறாங்க. அண்ட் ரீசெண்டாக வந்து பார்த்தீங்கன்னா அரௌண்ட் 300 கேண்டிடேட்ஸ் வந்து கெமிக்கல் இன்ஜினியர்ஸை வந்து பார்த்தீங்கன்னா ரெக்ரூட் பண்ணியிருக்காங்க. ஈவன் சயின்டிஸ்டாக போகணும்னு நீங்கள் ஆசைப்பட்டால் கூட வந்து பார்த்தீங்கன்னா நிறைய ரிசர்ச் இன்ஸ்டியூஷன் இருக்குது. நமக்கு உங்களுக்கு தெரிஞ்சது வந்து பார்த்தீங்கன்னா இஸ்ரோவில் வந்து கெமிக்கல் இன்ஜினியரிங் தான் வந்து பார்த்தீங்கன்னா இருக்காங்க. நான் சொன்ன எல்லா ஸ்ட்ரீம் சார் காமிச்சாங்க இல்லையா, ஸ்பெக்கர், ஐஓசிஎல், பாரத் பெட்ரோலியம், எல்லா இண்டஸ்ட்ரியும் நீங்கள் பார்த்தீங்கன்னா சென்ட் பீட்டர்ஸில் படித்த எல்லாமே, சென்ட் பீட்டர்ஸில் படித்த ஸ்டூடெண்ட்ஸ் எல்லாருமே அந்த எல்லா இண்டஸ்ட்ரீஸும் இருக்காங்க. ஸோ தட் ஹியர் நம்ம இன்ஸ்டியூஷன் சென்ட் பீட்டர்ஸோட இன்ஸ்டியூஷனில் வந்து என்ன ஒரு ப்ளஸ் பாயிண்ட் அப்படின்னு பார்த்தீங்கன்னா, வி ஆர் நாட், நாங்கள் வந்து பார்த்தீங்கன்னா எக்ஸ்ட்ரா ஃபீஸஸ்லாம் எதுவுமே வாங்குறது கிடையாது. என்ன டியூஷன் ஃபீஸ் என்னன்னு சொல்கிறாங்களோ, கவர்மெண்ட் என்னன்னு சொல்கிறதோ அதுதான் வாங்குறாங்க. ப்ளஸ் வந்து பார்த்தீங்கன்னா ஃபஸ்ட் இயர்லேருந்தே அவங்களுக்கு பிளேஸ்மெண்ட் ட்ரைனிங் வந்து பார்த்தீங்கன்னா அவங்களுக்கு வந்து நாங்கள் கொடுக்க ஆரம்பிச்சிடுறோம். பிகாஸ் இப்போ ப்ரெசண்ட்டாக இந்த ஃபைனல் பிளேஸ் ஆன பசங்கள்லாம் பார்த்தீங்கன்னா எல்லா டாப் இண்டஸ்ட்ரி இதில் வந்து பிளேஸ் ஆகிருக்காங்க. ஃபஸ்ட்டு வந்து பார்த்தீங்கன்னா கேர்ள்ஸ் தான் வந்து நிறைய பேர் பிளேஸ் ஆனாங்க. அதுக்கப்புறம் பாய்ஸ் எல்லாமே பிளேஸ் ஆகிருக்காங்க. இப்போ எல்லாருமே ஆல்மோஸ்ட் பிளேஸ்ட். இப்போது அதே மாதிரி நம்ம வந்து இங்கே கெமிக்கல் இன்ஜினியரிங் இங்கே பார்க்கும்போது லெபார்டரி ஃபெசிலிட்டிஸ் பார்த்தீங்கன்னா ரொம்ப நல்லா இருக்கும். இப்போ சப்போஸ் உங்களால் வந்து விசிட் பண்ண முடியும்னா ஆஃப்டர் த கோவிட் இஷ்யூ நீங்கள் வந்து டைரெக்டாக வந்து விசிட் பண்ணலாம். அண்ட் ஃபீஸ்ன்னு பார்க்கும்போது கவர்மெண்ட் ஃபீஸ் தான். அண்ட் லெபரட்டரி சார் சொன்னாங்க, இப்போ ஆஸ்பின் ப்ளஸ்ன்ற ஒரு சாஃப்ட்வேர் தான் நாங்கள் வந்து இண்டஸ்ட்ரியில் யூஸ் பண்ணிட்டுருக்கோம் அப்படின்னாங்க. அந்த ஆஸ்பின் சாஃப்ட்வேர் நாங்கள் வச்சுருக்கோம். இட் மீன்ஸ் தட் அப் டு டேட் கெமிக்கல் இண்டஸ்ட்ரியில் என்னென்னலாம் வந்து டெக்னாலஜி இருக்கோ எல்லா டெக்னாலஜியும் டீச் பண்ணுற அளவுக்கு ஃபெசிலிட்டிஸ் வந்து ப்ரொவைட் பண்ணி வச்சுருக்கு. ப்ளஸ் வந்து என்னென்னா பிளேஸ்மெண்ட் வந்து பார்த்திங்கன்னா நமக்கு பிளேஸ்மெண்ட் செல்லுன்னு தனியாக இருக்குது காலேஜில். அது இல்லாமல் டிபார்ட்மெண்ட்லேயே நாங்கள் வந்து பார்த்தீங்கன்னா ப்ளேஸ் பண்ணிட்டுருக்கோம். பிகாஸ் என்னோடய ஸ்டூடெண்ட்ஸ் வந்து பார்த்தீங்கன்னா எல்லா இண்டஸ்ட்ரீஸ்லும் வந்து பார்த்தீங்கன்னா ஒர்க் பண்ணிட்டு இருக்கிறதுனால, ஸோ ஐ கேன் ரெக்வெஸ்ட் பிளேஸ்மெண்ட்டுக்காக நாங்கள் ரெக்வெஸ்ட் பண்ணும்போது அவங்க என்ன சொல்லுவாங்க அப்படின்னா, ஃபஸ்ட்டு ஸ்டூடெண்ட்ஸோட எபிலிட்டியை பார்ப்பாங்க, இன்டர்வியூ வைப்பாங்க, நம்ம ரெக்கமெண்ட் பண்ணும்போது அவங்க வந்து பார்த்தீங்கன்னா எடுத்துக்கிறாங்க. ஸோ இங்கே சென்ட் பீட்டர்ஸில் நீங்கள் வரும்போது யூ ஹேவ் வெரி குட் குவாலிட்டி எஜுகேஷன். அண்ட் அப்பார்ட் ஃப்ரம் தட் the fees is nominal fees, and apart from that the placement is what definitely we are doing a placement if you study well. So if you are really interested to study chemical engineering, you can contact me at any time. Why? Because I am the admission coordinator. என்னோட நம்பர் வந்து பார்த்தீங்கன்னா ஈவன் அந்த 9940406406. உங்களோட அந்த வெபினார் இதுலேயே இருக்கும். அந்த வெபினாரில் இருக்கக்கூடிய கான்டாக்ட்ஸ் நம்பர்ஸோடு நீங்கள் கான்டாக்ட் பண்ணலாம். ப்ளஸ் ஐ வில் சென்ட் ஒன் லிங்க், என்னென்னா அட்மிஷன் ஃபார்ம். நீங்கள் வந்து பார்த்தோன்னா அந்த லிங்க்கை சப்மிட் பண்ணிட்டு யூ கேன் விசிட் அவர் காலேஜ் அட் எனி டைம். சப்போஸ் இஃப் யூ ஆர் ரியலி இன்ட்ரெஸ்டட், இஃப் யூ ஹோப் தட் you will get a job if you study chemical engineering in St. Peter's Engineering College of Technology. It will not force you at any cost. ஏன்னா ஒரு சிம்பிள் ப்ரெசன்டேஷனே வந்து பார்த்தீங்கன்னா ஒரு ஹையஸ்ட் டெசிக்னேஷனில் இருக்கக்கூடிய ஒரு பர்சன் இவர் தான் எங்களுக்கு வந்து பிளேஸ்மெண்ட்டும் பண்ணிட்டு இருக்காங்க. விமல் குமார் சார் வந்து பார்த்தீங்கன்னா இஸ் ஆல்சோ டூயிங் பிளேஸ்மெண்ட் ஆல்சோ. ஸோ பிளேஸ்மெண்ட் இஸ் நாட் அ பிக் திங் ஃபார் அஸ் இஃப் யூ ஸ்டடி வெல். ஸோ ஐ இன்வைட் ஆல் த ஸ்டூடெண்ட்ஸ் to come and visit our institution, laboratory and faculty members, and I hope that you can come and visit them. And if you are really interested, please contact us. And if you want to know more thing about the chemical engineering, definitely you can contact me at any time. Okay, thank you very much, and I wish you all the best for your bright future. Thank you. Is Hello, is Ray?
So can you hear me? Hello. Students, உங்களுக்கு ஏதாவது கேள்வி கேட்கணுமா யார்கிட்டயாவது? So regarding chemical engineering means you can ask now.
Is Ray?
Hello.
Is Ray கேக்குதா?
சார் எனக்கு கேக்குது. உங்களுக்கு கேக்குதா பேசுறது?
இப்போ கேக்குது. ரைட்டா? என்ன பேசுறது கேட்டுச்சா?
எனக்கு கேட்டுச்சு.
சரிம்மா, ஓகே. நீ என்ன பண்றீங்கன்னா நம்பர்ஸை ஷேர் பண்ணிக்கங்க. ரைட்டா?
Okay.
I think 18 participant is there. Prida, if they are really interested, Prida, ask them to fill the admission form. I will send the link. Right? Hello?
Okay, sir. Okay.
புரியுதா? அந்த லிங்க்கை வந்து சப்மிட் பண்ண சொல்லுங்கள். ஸோ தட் வி வில் கெட் அ application form from there. And then if you are really interested, let them come and visit our institution after the COVID issue. Right?
Sure, sure.
Okay.
Sir, shall we send them along with the feedback form link, admission forms
You
link?
can do it. And now, if anybody is what willing to ask any queries, okay, let them ask. Right? I'm ready to answer for that. இருக்காங்களா? யாருக்காவது ஏதாவது கவர்மெண்ட்லேருந்து ஸ்காலர்ஷிப் கொடுக்குறாங்கம்மா, கவர்மெண்ட்லேருந்து ஸ்காலர்ஷிப் கொடுக்குறாங்க, கம்யூனிட்டி வாய்ஸ் இருக்குது, எஸ்சி எஸ்டியாக இருந்தால் வந்து பார்த்தீங்கன்னா ஃபீஸே கிடையாது. அண்ட் ஃபஸ்ட் கிராஜுவேட்டாக இருந்தால் 50% ஃபீஸ் வந்து பார்த்தீங்கன்னா கவர்மெண்ட் வந்து கொடுக்குறாங்க. ஸோ ஃபீஸ் இஸ் நாமினல். ஆர்ட்ஸ் காலேஜுக்கெலாம் போனீங்கன்னா யூ ஹாவ் டு பே அரவுண்ட் 40,000, பட் ஹியர் within 30,000 you can what do you call that, get your chemical engineering degree. And apart from that, those who are studying very well, college is also providing what do you call that, a scholarship. Okay, for meritorious students we are also providing scholarship. அதனால வந்து பார்த்தீங்கன்னா கவர்மெண்ட் கொடுக்கக்கூடிய ஸ்காலர்ஷிப்பை வச்சுக்கிட்டு எந்தவித செலவு இல்லாமல் அழகாக ஒரு வேல்யூபிளான ஒரு இன்ஜினியரிங்கை முடிச்சுட்டு and then you can settle in your life like anything. That is my request to all the participants, right? ஏன்னா நிறைய பேருக்கு வந்து பார்த்தீங்கன்னா இன்ஜினியரிங்ன்றது தெரியாமல் இருக்கு. And don't think that chemical engineering is only suitable for boys. It's not like that. Okay, irrespective of gender, chemical engineering is suitable for everyone. And nowadays எங்களோட டிபார்ட்மெண்ட்ல பார்க்கும்போது 50% வந்து கேர்ள்ஸ் தான், 50% பாய்ஸ். அவங்க எல்லாருமே வந்து பார்த்தீங்கன்னா ப்ளேஸ் ஆகிட்டு இருக்காங்க. ஓகேவா? ஸோ இஃப் யூ ஹேவ் எனி queries you can ask me, right? ஆமா,
ரித்திகா, ஏதாவது கொஸ்டின்ஸ் இருக்காமா உங்களுக்கு?
சௌந்தர்யா கேட்டிருக்காங்க. ஜி சார், this COVID-19 destroyed so many engineer profession. I came to know that many companies reduces their production. In this affect the chemical production, petrochemical production engineers in future. Tell about the opportunities for above mentioned position. Listen, I think Soundarya, the COVID ப்ராப்ளத்தினால லே ஆஃப் பண்ணதெல்லாம் எப்படின்னா, லிசன், ஒன் மோர் திங் இஸ் தேர். சைனா வந்து இந்த கோவிட் ப்ராப்ளத்தினால சைனாவில் நிறைய ப்ராஜெக்ட்ஸ் வந்து பார்த்தீங்கன்னா டிஃப்ரெண்ட் கண்ட்ரிஸ் வந்து ஆரம்பிக்கிறதா இருந்துச்சு. ஆனால் சைனா பண்ண ப்ராப்ளத்தினால இப்போ எல்லாருமே நெக்ஸ்ட் எங்கே ஆரம்பிக்கிறாங்கன்னா இந்தியாவில் தான் எல்லா இண்டஸ்ட்ரியும் ஆரம்பிக்க போகிறாங்க. ஸோ ப்ரொடக்ஷன் சைடில் இருந்து அண்ட் மொபைல் ஃபோன்லேருந்து செமிகண்டக்டர்லேருந்து நிறைய மேனுஃபேக்சரிங் வந்து நம்ம இந்தியாவில் ஆரம்பிக்கிறாங்க. அதனால் இன்னும் 3 இயர்ஸில் வந்து பார்த்தீங்கன்னா இன்ஜினியரிங் ஸ்கோப் வந்து பார்த்தீங்கன்னா இட்ஸ் கோயிங் டு வாட் இன்க்ரீஸ் லைக் எனி திங். அதே மாதிரி ப்ரொடக்ஷன் சைட் பெட்ரோகெமிக்கல்ஸ்லாம் வந்து பார்த்தீங்கன்னா எந்த இதுவும் வந்து பார்த்தீங்கன்னா ட்ராப் இருக்காது. பிகாஸ் we are purely depends upon the chemical in all aspects, so that there will be no worry about reduction in manpower. புரியுதுங்களா? இது என்னன்னா ஸ்டாண்ட் பை வச்சிருப்பாங்க அந்த ஃப்ளக்சுவேஷன்ஸ் ஆனே தவிர இது வந்து பார்த்தீங்கன்னா பர்மனெண்ட்டே கிடையாது. புரியுதுங்களா? ஸோ தட் கெமிக்கல் இன்ஜினியரிங் படித்தா எந்த ஒரு ப்ராப்ளமும் கிடையாது. Told me that AI equipment is. Is there any other doubt? Any doubt? Any queries?
Hello. சௌந்தர்யஜன், ஈவன் இப்போ ஸ்பீக்கர் பண்ணவர் வந்து ஆக்சுவலா இஸ் ஒர்க்கிங் ஃப்ரம் ஹியர் டு அ குவைத் கம்பெனி அண்ட் இஸ் டூயிங் லாக்டவுன். த ப்ரொடக்ஷன் ஹஸ் நாட் ஸ்டாப்ட். ஆக்சுவலி இஸ் ஒர்க்கிங் ஃப்ரம் ஹியர் இட்செல்ஃப்.
இந்த லாக்டவுன் பீரியட்ல ரிஃபைனரிஸும் சரி அண்ட் ஃபார்மசூட்டிக்கல் இண்டஸ்ட்ரியும் சரி இதுவரையும் ஒரு நாள் கூட லாக்டவுன் இல்லாமல் போயிட்டு இருக்குமா? ஸோ தட் நோ நீட் டு வரி அபவுட் திஸ், ரைட்? கெமிக்கல் இன்ஜினியர் தான் pharmaceutical industry ரன் பண்ணுறது. அதனால யூ ஹேவ் வெரி குட் ஸ்கோப். அண்ட் ஆல்சோ சார் கேர்ள்ஸ்லாம் வந்து பிளான்ட்டில் ரன் பண்ணணுமானா கிடையாது, அவங்க டிசைன் பண்ணலாம், ப்ராசஸ் கண்ட்ரோல் இருக்குது, நிறைய ஸ்ட்ரீம்ஸ் வந்து பார்த்தீங்கன்னா இருக்கிறதுனால கேர்ள்ஸ்லாம் வந்து பார்த்தீங்கன்னா நிறைய ஆப்பர்ச்சுனிட்டிஸ். எங்களுக்கு வந்து பார்த்தீங்கன்னா ஃபஸ்ட்டு ப்ளேஸ் ஆகிறது கேர்ள்ஸ் தான். ஸோ தே ஆர் கெட்டிங் வெரி ஹை பே ஆல்சோ, ரைட்? ஸோ நோ நீட் டு worry about all those things. Is there any query? Great.
So we can conclude, sir.
Okay, thank you very much, dear participant. If you have any doubt or if you want any clarification, you can call me or you can contact me at any time. And definitely we will clarify all your doubts, and then definitely we will guide you whether you are joining over here or somewhere else. Definitely we will support you all. Right? Thank you very much.